Hello, everybody, and welcome to the Atlanta.net Users Group COVID edition for end of March. Glad you could make it. And I don't really have a lot of community announcements or things going on because there's just not a whole lot going on. If you're plugged into the different meetups currently, I'm sure they're sending out notes about their virtual meetings. I know there's a few of them going on here and there, maybe not as tightly scheduled as they used to be. I will also tell you that we are working on the Atlanta.net Code Camp planning. We are trying to find a way to do it this year. I know everybody missed it last year, so as of the time of this meeting, at least, we're still in talks around it. We don't know yet whether it'll be something we can do in person or if we're going to try and do a virtual version of that. So stay tuned. We'll be letting everybody know as we get more information to share. But for tonight, we're going to be talking about improving your code quality with static analyzers, and Jim Wooley, take it away.
Thank you very much, Ken. Yep, my name is Jim Wooley. I am with Slalom Consulting. We're a national consulting firm with a local model, and we have office here in Atlanta, and also all the way across the country. I know we have some people that aren't just local here that are sitting in on the sessions. So if you're interested in consulting, either from needing consulting services or being a consultant yourself, feel free to reach out to me, and we can have a conversation at some later time. And that's enough for the sales pitch. What I want to focus on today, however, is static analysis. Using static analysis tools, we'll understand what those are, also how that fits into sort of the broader category of what I like to consider as code quality. And then hopefully by the end of this, we'll even get into the ability to not only use some static analysis tools, but also to build one yourself. So hopefully, regardless of your skill level, you'll be able to take something out and be able to use it tomorrow, and go from there. So as I mentioned, as we're waiting for others to join here, the links here. The first link is a link to a bunch of my various presentations, including this one. The second one is a link to this presentation specifically, and it's more around the demos than it is the slide deck. Because I don't know how much slide deck is necessarily going to be useful for some of you, but I can make sure that I'll share the slide deck out and put it in the Teams meeting as well for people to reference. And then the third one is if you like what you see regarding creating your own Roslyn C# analyzer, because this is a .NET meetup, so I'm going to have a fair amount of C# code in here as well. I do have a set of hands-on labs that I created. They may be slightly out of date. I built these about 3 or 4 years ago, and there have been some API changes and some slight differences in how you do things. But I leave the old version out there. It's open source, so if anybody wants to contribute back and update it and find any bugs that I have in there, I'm willing to take pull requests. But also I find that one of the best ways of learning is by fixing somebody else's mistakes. So if you see any mistakes, feel free to go out there and learn more, figure out what the answer is, and then you're really going to learn it. At least that's what I tell people, whether they believe me or not. So improving code quality with static analyzers. I sort of mentioned who I am a little bit. I have a website, ThinkLink. Wrote a book on Langco probably 2006, I believe, and I still get a royalty every now and then. So if you bought a copy of that, I appreciate that nickel of my royalty part. My Twitter alias at Jim Wooley, and I'm a Microsoft MVP and Visual Studio Tools, or they keep on changing the name of this particular one, but it is Developer Tools now, I believe. And I'm no longer a solution architect with Slalom Consulting. I'm a senior delivery principal. They've changed our little bit of the titles, but still I do pretty much the same kinds of things. Help teams try to build applications and deliver those applications for customers. So I want to talk a little bit about code quality before I dive deep specifically into static analysis, because it sort of fits into this little pyramid of things that we have to do for applications, right? So what is quality code? Well, first of all, if it doesn't compile, obviously it's not quality. So, the first unit test is, can it compile? Then secondly, hopefully you have a suite of unit tests, integration tests, those kinds of things to make sure that is my application not only compiling, but is it doing what the business wants it to do. Another thing that you need to do is to agree on some sort of a style where your team is going to collaborate. And even if you're an individual contributor, you're the only person on this particular project, even if it's your own individual project, I find it helpful to stick to a set of like naming conventions and standard practices that you're going to use in your applications. So that way, when you you put it down for 6 months and you come back to it later, you know where to look for things and what you're going to name things, and it applies also as part of a team. But like in consulting, we'll build stuff and then hand it over to a customer to finish, continue to maintain over time. And I want to make sure that the code that I hand off to them is quality, that they can maintain it. They don't have to learn a whole new set of paradigms on how do I work with this code. It uses the same idioms. Now that style guide doesn't have to be a really big tome that you go out and have to write. In many cases, it can be something very small and very simple. And oftentimes you just leverage what are the existing style guides for that particular language or industry. So for example, C# has a different convention for the open curly, close curly as JavaScript is. And so you want to sort of follow the convention of that particular language. Now, for example, the Roslyn team, that's the C# compiler team, they have a style guide of what do we expect if somebody's going to contribute back to the Roslyn code base? And this is the C# language team themselves. And you would think that a team at Microsoft would probably have this really big thing. Well, no, it's about a page and a half. And that's probably a good guideline of where you should be for coming up with something which is going to be fairly standard. And I recommend, even if your company doesn't have a style guide, look at some of the ones that are already out there, from the C# team, from the .NET teams, for example, on, what are the kinds of styles that they recommend, and try to adopt that, find where it meets yours and where it doesn't meet yours, because we really don't want to have this conversation of tabs versus spaces now, do we? Right. So once we have the style guide, then we can apply that with maybe a set of static analysis tools, which are able to evaluate your code, review that, and be able to help you adhere to whatever those styles are. And it may be that you'll find one of these tools will have additional styles that you don't agree with. Well, one of the key things we'll talk about is make sure when you select one that you can select one which you can customize and make it agree with what it is that you say that your company really should be doing and using. Then the next piece of code quality comes into peer reviews. We do peer reviews on applications all the time. Anytime we have a pull request, I make sure to go out and review that. I know at least one person on the chat here can attest to how thorough I am on my pull reviews. And make sure, does this agree with what we're doing? Now, hopefully, if you've applied the static analysis checks already, you've had the system go out and do the drudgery of figuring out, are they putting the right number of tabs or spaces or curlies or semicolons and all of these kinds of things. And definitely the static analysis goes deeper than that, as we'll see here. But that way, once we allow for the tools to be able to manage the things that a tool can recognize, then the peer reviews can focus on things that can add business value, making sure that the application is doing what you say it's supposed to be doing, and not just that it looks right, right? And hopefully, as part of code quality, you'll have some sort of a continuous integration and even continuous deployment, so that you're not, building this on the lead developer's desk under his desktop and publishing directly from his desktop. We really don't like doing that when we're writing applications. It's not reproducible. We want to make sure that we can have, reproducible methodologies which take sort of that human element out of the mix. And then some of the code quality tools and static analysis tools allow us to see sort of trend analysis to see, is the number of bugs that we're having increasing? What's the amount of code churn that we have? If we have a high amount of code churn right before we're getting ready to deliver, well, maybe there's a problem with our application. We may want to push our delivery date back, right? Is the code quality increasing? Is the amount of unit test coverage increasing or decreasing? And being able to see these kinds of things over time can give a nice little benefit there. So of this little triangle of code quality, two of these sort of stand out from the others in that they are different from the other ones. So just take a minute and look at this and try to figure out what's different between the darker colored ones and the lighter colored ones. And usually I would ask you for hands raised and things like that, but since we're remote, I won't do that for today. But what I'll say is the key thing with the style guide and the peer reviews is that requires people. Right. Of course, yes, it requires people to write unit tests, right? But to execute them, to make sure that we don't have a regression, all those kinds of things, you can automate those processes. Static analysis tools are another one where you can have it automated, check that so that your people, and you can use the have your brain power to then focus on things that add business value. So what is static analysis? I think Wikipedia has a decent description of it. And one of the key things to this definition is it allows you to perform it on code that can't even compile potentially. And so this is looking at your source code and making sure that your source code is agreeing with these standards that you've decided across for your programs. And then, we can see whether it compiles or not as a sort of separate process. So we want the ability to look at our code, not just the compiled executable. So if you think about it, what would it look like if I was on a team that didn't have any of these pieces? I didn't have any rules and standards around how the code is supposed to look, and everybody's able to do whatever they want whenever they want. Would we end up with a team that looks like this, where it's each man to himself, and nobody caring what everybody else is doing? Hopefully, this is not the kind of team that you want to be on. Right, you want to have some sort of organization, so that once one person writes code, somebody else can pick that code up and just be able to work with it, even if that's yourself. So, but obviously I don't want to go with the opposite extreme where you say everything needs to be exactly like this and nobody has the ability to think for themselves. Everybody has to do exactly what I tell them and only what I tell them. And the problem with that is you get no creativity and no thinking outside the box. And so the applications that people write just don't really have much creativity. And so what I like to think about is sort of a jazz ensemble where everybody, they sort of have their own place to play in with the team, but they also have the ability to riff off of other ideas and bounce ideas off of other people. And so when we start doing that, then we have the ability to create these marvelous things that could have never happened in isolation by themselves. And everybody has a similar harmony and similar rhythms and melodies that are sort of guiding how the song's supposed to go, but they are given that freedom. And this is the kind of thing that I like to empower my teams with. I don't want to give them a dictate of a 100-page coding standards documents that they all have to adhere to and memorize. There are exceptions to every rule, and so make sure that you're abiding by those kinds of things. So why would you want to use some of these static analysis tools? One is obviously to standardize within your team. Make sure that the various people in your team are being able to share the code, be able to understand it, and maintain it all together. And so, yeah, that does increase the maintainability in that regard. Allow the code review to focus on domain logic. You can detect specific errors that maybe the compiler doesn't detect. So for example, certain domain-specific languages have certain idioms of this code needs to work, behave this way in order for it to be able to run. It'll compile, but maybe it won't run. And so maybe some tools that can be able to check that. Another one may be to fix code smell. So what's a code smell? Yeah, this slide's a little fishy, I guess. Let's get my syntax checker out because the PowerPoint static analysis tool just didn't work very well for me. So we want to fix code smells. Well, what's a code smell? We've all probably seen code that looks something like this. We have a big set of long line list of code that has multiple nested indentations, and there's lots of different kinds of things that are happening here. It's really impossible to unit test because there are too many side effects that are happening inside. And on this one, I actually where it said do nothing. Well, how about if I switch that do nothing and flip that around and have no else clause and have flip the inverse of the tool around. And so it would be nice if we could have tooling which could look at this and try to guide us to writing better code. And oh yeah, like maybe a tool can tell when you have the flock of seagulls with all of the curly braces closing at the end there, right? In fact, I even had one architect on a project previously which insisted that we include code comments at the end of brackets because the bracket was so far away from where we created it that you couldn't tell what things were happening. To which my answer is, make your code do less and refactor that so that you have more concrete individual parts, and maybe rename that thing that you've refactored out to the name of what you put that code comment to be. Just makes for much more readable code. And in fact, if you, in Visual Studio, for example, if you hover over these lines here, it'll tell you anywhere in your code where it actually started from. So you don't even need to do that kind of thing. So it'd be nice if we could take some tools, be able to refactor that, find the code smells, make the code much more maintainable, much more testable, just by flipping some things around. Instead of nesting in this if customer is not equal to null, maybe I can say if it equals null, then return and escape out, so that I can then collapse that first bracket in. As I said, invert the logical operation of this one, so I don't have to worry about an else clause. And multiple other things that are inside of this code, right? We've probably all seen code like this. We've all optimized that code. It'd be nice if some tooling would be able to help us to find some of those kinds of things. And we'll see some of those when we go through today. Names are hard, right? How many times have you seen something like this, where I'm passing in an input parameter that's int x, and then I'm doing x equals x and assigning x to x? Well, what's the result of that private int x at the end of this? It doesn't change because it's reassigning the input parameter rather than the other one. And very often I've actually seen cases where this will cause a Stack Overflow exception because it kept on setting the wrong variable all the way up the stack. So making sure that we're naming things appropriately. And for God's sake, don't use single character variable names, okay? That's an easy one. Security vulnerabilities is another typical way that people are using some of these static analysis tools. And I found a study a couple years ago where they looked through GitHub, and they basically just did some regular expression checks over GitHub repositories, and these are all public repositories. And they found that 1,000 valid secrets, we're talking about passwords, we're talking about API keys, we're talking, all of those kinds of things. Secrets are committed to GitHub each day. 94% of them were considered sensitive. 6% remained or were removed within an hour, only 6%. 80% of them still remained after 2 weeks. And one of the interesting things they actually found on this one is, yes, you can remove something from your Git repository, but once you've checked it in, it's part of that history, right? Well, there are ways with Git that you can overwrite history. However, realize if you know the original hash, you can actually go back and get that original value of that secret. So, having a tool that not only can find those secrets to make sure that you're not committing them, but yeah, if you have secrets committed to your repository and you're in a public repository, you might want to go and jump out of the session real quick and take a look and fix that for you. Okay. Another thing is maybe detecting domain-specific errors. So here's one where we have a class. It's called test controller misnamed, which might be a clue as to what the problem is. This derives from controller in MVC. And will this code compile? Sure. But what will happen when you actually try to run this? You won't be able to actually hit the controller endpoint because MVC uses a convention-based approach over the names of the classes to the controllers. And so if the controller doesn't end in the word controller, then the routing mechanism, the default routing mechanism, which is built into MVC, won't be able to find this particular controller endpoint. How do I know this? I banged my head against the wall numbers of times, so hence the bumps on my forehead here. So it would be nice if you had a tool which could then isolate, hey, there might be a problem with this code. It's something fairly easy to find. just see any class that derives from controller and doesn't end in the right name, I can tell the user not only is this a problem, but maybe I can actually tell them how to fix it. We'll actually step through this one here at the end of the presentation. So another common thing is just recommended best practices. So making sure that you're disposing of things that you should be disposing. Don't try catch and just catch a general exception. Catch only specific exceptions and let generic exceptions bubble out to where you can actually apply them. If you have a variable which is allocated, which is no longer used, being able to isolate that variable may be taking up memory footprint that you shouldn't be using. Maybe recommending that if you're in a globalized application, that you should be using globalized string comparisons and date formats and currency types of things in your applications to make sure that you're abiding by what are the guidelines. And of course, in some of these cases, maybe one rule applies for one application and it doesn't apply for another one. So for example, if you're building a mom and pop website for a blog, first of all, you probably don't need to be writing your own blog engine, but if you're wanting to do that, then you probably don't need some of the globalization stuff. But if you're writing an international financing application, which is being used across the globe, maybe those things are important, right? And so you might want to make sure that you're actually abiding by those. You can also use tooling to be able to find what are hotspots in your application. So maintainability issues. This is the code metrics. This is inside of Visual Studio, for example. And then here we see some of these, the maintainability is fairly high, like this data is a 92 maintainability index out of 100. But there are other cases like the API DLL, which is only 69, in part because it has high symptomatic complexity, which means each method has multiple paths that it can go through. And maybe the inheritance level is fairly high. So here's a depth of inheritance in general is a 9. So you might want to be able to reduce the amount of things that are inside that application and pull things out so that you have more maintainable code over time. Also, I don't know about you, but it's hard to stay on top of the new things that come out, the new trends. And sometimes what used to be the way of programming gets changed over time. So for example, if you've been following along with C#, we had up until 2010, I think it was, things were fairly stable. We only had up to C# 4. But in the last 10 years, we've already jumped up to C# 9. And in fact, with C# 8 or C# 8, we not only had C# 8, but C# 1, 8.1, 8.2, and 8.3. So there's, trying to stay on top of things that are happening it can be very difficult. And so sometimes it might be helpful to have tooling that can say, well, in the old world, we might have written things like this, where we had an out parameter and we had to declare the parameter beforehand, which we're not allowed to use, and we just consume it inside of here. But with C# 7, they decided, well, maybe we can have an out var, and then not even have to pre-allocate to that particular variable, and just say out datetime output, and declare the variable directly in line here. And so one of the things that they added with Visual Studio at the time was to automatically have analyzers which can detect that there's a newer, better way of doing things, recommending that, and also telling them, and here's how you do that. So it's a great way of learning. I don't know how many times when I've used some of these static analysis tools that it recommends something I didn't even know was an issue. But as I look at it deeper and find out more about it, then I can say, oh, now I understand what's going on. This is why it should be better. And we can get better on our code as well at that point. So let's see here. Let me keep on going here just a little bit. Go. So there are numbers of tools out there for doing these kinds of things. I can't necessarily have an exhaustive list of all of the possible tools. These are just a handful of the tools that I've found useful. I'm sure that you have some favorite tools that aren't on this list. Wikipedia does have a fairly good list of static analysis tools for each of the various languages: C++, Python, Ruby. Name the language, and there's probably some sort of a tooling out there. Now, not all these tools are free, so sometimes you get what you pay for, but other ones are free. And a lot of the ones that I've identified on here, probably with the exception of Sonar, are all free for use. Let's see here, CodeRush, ReSharper, those are also commercial tools. If anybody knows a tool that they love, feel free to put it in the chat window that I haven't included here, and so that we can all learn from other tools that you would recommend and be able to benefit from. Okay, so what can one of these tools do for you? Let's jump into a demo. So let's start off with the language that all of us have to know at this point. I don't think there's any way of not knowing this is JavaScript, right? And so let's think, if we had a program like this, very simple application, doesn't really do too much, looks fine, right? But there's some problems with this code. Can you see what any of those problems are? Well, my little squiggly lines here don't really give you much of an indication because I don't have any tools turned on for it at this point. So let's go ahead. I'm going to pull up code and pull the same code up here and see what we can do about actually finding some of these problems. Whoop, you saw the end there. So we can do about finding problems and what we can do to fix those problems. So right now it says, yep, no problems. We're great, right? Well, let's go ahead and pull in a linter and see what that linter can do. So in VS Code, there are lots of extensions. I can add extensions. I've already installed some of these extensions before we started here. I'm going to turn a couple of them on, or one of them on in particular. Let's turn on JSLint. JSLint's one of the older ones. And this was actually created in part to abide by Douglas Crockford's JavaScript, the Good Parts book, and the recommended parts of JavaScript that you should be using as compared to those that you shouldn't be using. So if we come back into this lint this example, we can say, oh, we actually have some challenges here, right? So how many of these were you able to find before I turned this on? Well, here's the first one. Well, the first one is we expect to use strict before we return something. So let's go ahead and use strict. If you don't know what that does, then you have some research to go out to try to figure that out yourself, right? So use strict, make sure that you allocate variables. With JavaScript, you don't have to allocate a variable before you use it. Use strict to sort of makes you try to allocate those and not just use things that you didn't create. Because I don't know how many times I've used a variable and then maybe mixed up the case later on in my application so that then I've allocated a different variable instead of checking a value that I thought was actually there. Now, the next thing is it's expecting things to be at column 4, not column 2. And the standards there are a little prescriptive, but we'll go ahead and abide by that. And one of the challenges with JSLint is you don't have as much ability to customize it as compared to JSHint, which started off from JSLint, but then added a customizations and extensibility points to it. And there's also ESLint. If you've used TSLint before, for example, TSLint is now actually deprecated in favor of ESLint. So if you want, you can go ahead and just use ESLint as well. I'm going to stick with JSLint for right now. So now I've fixed those two. I got 6 more problems here. Now, first one, it says, this is unreachable code detected. Why is that unreachable? Because I'm returning hello world there, and thus the rest of my code in the application isn't even being run. So that might be a problem. Maybe I just had a debug point there that I accidentally left in. So let me go ahead and remove that. And now I have var x equals 1 if x equals 2. And what's wrong with that double equals? Well, it's doing a type coercion, right? So I want to make sure that I have a triple equals. For good JavaScript conventions. And obviously, in this point, we know that those actually can't be the same because a number and a string are never actually going to equal. So let's go ahead and fix the typing on that one a little bit. Even if we're not in TypeScript, we can do some typing there. Now, the next one is, this looks fine for me as a C# developer, but if I had a JavaScript developer, a Node person come in and took a look at my code, they'd say, oh, you don't know how to use JavaScript. You put your curly brackets in the wrong place. So I'm not going to trust the rest of your code at all. And we don't want that with our code. We want to make sure that we're abiding by good standards. And then the next one, we're going to log X. Well, where's X been? X isn't defined anywhere, right? Because we have the wrong case on that one. So I want to make sure to use the right casing on that. And I want to go ahead and apply the semicolons like we should. Be good corporate citizens here with our semicolons. And then console is undeclared. And this is going to be sort of a hint to the linter itself, where I can put in a comment that I have a global for console. And then at that point, it's going to say, well, I'll just go ahead and trust that whatever you set off a console, you know what you're really doing here. And so I'll trust you and just go with it at that point. And so anything you want to call on console, you're good for. If you want to go beyond that, probably looking at a TypeScript or something like that. One of the great things about TypeScript is it gives you a compiler as one of your unit tests, whereas JavaScript doesn't really have that compiler built into it, right? So, just in this simple code, we've seen how we can catch errors that would have, hit us at runtime. We wouldn't have known about them any other way unless we had a whole suite of unit tests, which I highly recommend as well, obviously, as part of code quality. But our code looks more maintainable. We fix some bugs in our code just by using one of these tools. That's pretty nice, right? What about maybe CSS, right? So here, I'm not necessarily a good designer, as you can tell from if you've ever seen any of the applications that I write myself without a designer that's involved. But I can make do with CSS. But sometimes you might be able to learn some things, some better ways of doing stuff with CSS. So here I have CSS hint, style int rather, installed. And StyleInt's telling me that, hey, there's some problems with some of the indications that I have here. So for example, margin at 0px. Well, why is that a problem? Well, we don't need a unit indication at all if it's 0. Right? 0 is 0, regardless of whether it's EMs or PXs or any other measure. So we can just go ahead and say margin is 0. But the next one, it says padding is 5px. Well, that looks perfectly valid, doesn't it? Well, it says I have an unexpected unit px. Well, when I set this application up, I actually set it up so that I was telling my designers told me that I don't want you to use pixel measures. I want you to use EMs rather than PXs. Okay, so I just went into the StyleInt RC and I made sure that PX was not whitelisted in my application. Now, I could just go ahead and PX and do that. And now if I come back over here, sometimes you have to force the tool to refresh itself, but now I've refreshed it, says, oh, PX is great, wonderful, it works in my particular domain. But this comes to the point of you need a tool when you select your tools that you can customize and adapt it to your particular style guides, which obviously means that you have to have some sort of style guide, right? So make sure that you're paying attention to, can I make this work for us, rather than can I just apply this big thing and it does way too much. I don't know how many of you that do C# ran into the whole problem. If you want a little hand raised on the teams, any of you back in around 2005, I think it was when it first came out, there was a tool called FXCop. And this is a great tool that you're going to use in your applications to find all of these kinds of problems yourself, right? And so you install FXCop on your application that has 200,000 lines of code. And it came up saying, hey, there are 2,000 problems in your application. So you look at them, you research every single one of these 2,000 issues, you figure out what the problem is, you tediously go in, make the modifications, fix all of your code, and then you try to compile again. And what happened at that point? You got 2,000 more errors because they actually, from performance perspective, said, as soon as I hit the first 2,000, I'm going to stop looking through the rest of your code. And then you run it again, I get the next 2,000 and the next 2,000. So what do you do after that? Uninstall it. Uninstall FXCop and keep on working from there. So the better thing is to tweak it to match your particular needs. Okay. So we've looked at a little bit of JavaScript. We looked at a little bit of CSS, and there are bunches of tools out there. Again, I don't necessarily say you have to use this particular tool, but I do recommend use a tool to be able to automate these kinds of things. And you're also going to find you're going to learn a lot because of doing that. So let's, at this point, this is the .NET meetup. So let's jump out of the web world and let's go right into maybe some .NET code. And I'm going to pull up Visual Studio, and I have some code samples here that we'll take a look at. So here we have a C# application. We have these language improvement tests. And if I take a look down on my error list, I can see that there are no errors. Great, I'm compiling, I'm going to ship it, right? Well, hold on, there might be some problems. I might want to take a look at some of these and get these resolved first. So the first one is, it says unreachable code detected, and this is in the warnings. So we have warnings and info. And you can see up here, we have, see here, unreachable code detected. Well, if I take a look at it here, we have unreachable code. Why is var person equals to get Jim unreachable? And why is my screen drawn quite that way? Let's try that so that you can see a little bit better. Well, if we look at this, okay, we have the if block, and then we do something, we throw an exception, then we have our person. It looks perfectly fine, right? Not so fast. This isn't Python. So we want to make sure on our if blocks in C#, if I don't have brackets around it, only applies to the first line. Indentation doesn't matter, right? And there's actually a code recommendation on here that they added, which says that in C#, they recommend all if blocks have braces around them to specifically be able to catch this particular scenario. So now we see, oh, that if block only applied to the one thing, it doesn't apply to the throw. I want to actually put that inside of the throw block. And now we don't have that other method that's actually calling into that. Another one here, we say the variable EX is declared but never used. Well, where is that one? Right here, we have a catch. This catch isn't doing anything, and it's catching with a variable. And whether you know it or not, if you catch it with a variable, then there's actually a memory and a performance impact that without a variable doesn't happen, because they don't have to actually capture the state of the application if you don't catch the exception. So I could either make that modification, or I'm going to hold on to this one for just a little bit more. And we're going to come back to this one after I apply a couple other static analysis tools. So let's look over at my language improvement one. I have a similar code block here. I can add the braces in the code block, make sure my do something else is applying where I'm expecting it to. Here I have a local variable int x in the out parameter. So you can actually make a modification here, and see on the index, I can inline the variable declaration. And if you're not sure how I'm doing this, I can either hover over the problem that it's seeing and click the light bulb on it to light that up. Or if you're using Visual Studio and keyboard commands with the standard keyboard mappings, I can just on the line that's a problem, do Control dot, and it's going to bring the exact same thing up to you, Control period. And so one of the best productivity tools I ever learned was doing Control dot. Unfortunately, it's not very discoverable. So that's why I'm telling you about it right now. So here I can inline that variable declaration. And if you're not sure, what does that mean? Most of these are actually going to have links that you can click on, and it'll take you out to a web page that will describe exactly what the problem is and why it's there, what it's going to do, and how it's going to be able to fix it for you, right? With examples. So it's a very good way of learning what are maybe some better practices of how I can do these kinds of things. So let's go ahead and apply that one. And we'll see that now we don't have to declare that outside of the method. We can actually declare it directly inside of our if block using a out variable. We can actually use out var here instead of having to declare the variable type, and life's good. Okay, so the next one, we have var p equals new person, and maybe we want to simplify that object initialization, make that a little more concise in our code, and improve it that way. Let's see here. We have some other ones. Here's one that was added, I think, with 2017 on this for each var person and people. Now, if you use ReSharper, then you're probably most familiar with this one, but they added in 2017 the ability to convert a for each statement over to link. And so me as a link person, I have to love this particular way instead. If you don't like that one, you can easily undo that. You can invert operations and all those kinds of things as well. So there's a bunch of these tools and techniques that you can actually leverage. Let's see here. We have also not only the warnings, but also the messages. And messages are recommendations, but they aren't necessarily potentially going to cause a problem. So here I have the name can be simplified. I have a string format. Okay, so we're going to use the lowercase string rather than the uppercase, and that's going to be better. And now I have string formats. His parent is passing in parameter 1 and person parent name. Anybody see any problem with this code? I hope so, because what's the index of that parameter? Index of the parameter is 0, not 1, right? So with string format, I should be able to convert to an interpolated string, one of my favorite features of C#7. But if you notice here, it's not going to actually convert it to an interpolated string and put the parameter in because it's a wrong parameter value in there. So I actually want to fix that before I do it here. Make that 0 and make sure I don't lose the brackets there. And now if I do string format and make an interpolated string, you'll see that that actually is interpolated properly. And if you're not familiar with string interpolation, one of the great things about that is now I can get IntelliSense inside of a string. Awesome stuff, right? See here, what else does it like? Well, we already talked about the EX there. We're going to come back to that a little bit later. Unused parameter. Okay, so now we have can vote, and we're passing in a minimum age. And we're not actually using that anywhere in our code, so I can actually remove that, change the signature of that, and remove the parameter that we're no longer using, and simplify our code. We don't have extra variables, so we don't need to. And not only does it change it here, but anywhere that was calling into it, it also removed that parameter at that point too. Maybe on this, maybe the code's a little more complex than it needs to be. Maybe I can, instead of make the evaluation in the if block and then returning true, else return false, maybe I can just return the output of that particular method. And maybe I can make it a little functional and simplify it even more. So now we can take advantage of function expressions in our code there. Okay, next one, recommendation says that this should be a read-only modifier because we're not actually changing this value anywhere in our code. Well, that's great, but I can see that I actually have maybe more of those. And right down here, I have multiples of the 044. And so maybe I want to go ahead and not change this to read-only, but not do this only for this one, but also change it for all of them in the document, in the project, in the solution. I'll go ahead and just change it in this document. And it's going to give you a preview of the ones that it sees. And you can just go ahead and say which ones you want to apply it to. And it'll apply that directly to those, right? Whoop, it actually didn't. It changed the scoping of that. I want read-only modifier in the document. There, that's a little bit better. Okay, and see here, another name can be simplified. That's good. Another string interpolation, even better. I love removing code. If I got paid for every line of code I write, I would owe a lot of money over my career. Let's see here. We don't need to initialize the Boolean to false. We can do it more inline, and also remove another unused parameter. Okay, and we'll remove that. Good. Well, it's not using the right pattern, so I'm going to go ahead and keep that in there for now. Because sometimes you will find that a rule maybe we actually shouldn't undo it, right? So let's go ahead on this particular rule and customize our application to handle that particular rule differently. So in this particular case, I'm going to suppress or configure issues, and I'm going to configure the severity of this particular rule. I can either do it in line to this particular method, or I can do it across the entire project. In this particular case, I don't want to suppress this everywhere. I'm going to suppress it only in this particular line of code. And that's going to add a pragma around that line of code saying, I've reviewed this, I've checked it, and yes, this is valid for this particular case in the code. Now, sure, you could go ahead and apply these otherwise. And as I mentioned, right back when we did the static analysis with the FXCOP originally, you found all of those errors that came into your code, and it got really cumbersome really quickly. So they have added a little feature which you could take advantage of. And if I go into here with analyzing code cleanup, you'll see that there is an option here to build and suppress active issues. So let's say we add a new analyzer to our project, and it finds 10,000 problems in our code base. Well, if it's an existing code base, we might not want to go in and change all of those existing ones. We may want to only apply the code analysis to new code that we write. So you can do this. I'm going to recommend that you don't, because realize what this is going to do is it's going to go through your code, and every place that it sees a problem, it's going to add that pragma around your code, and your code's going to get to be messy really, really quick. My better recommendation is to go in and tweak the rules that you actually have in your code base. So there are numbers of ways that you can actually tweak the rules here. Let's go back to my sample here. And let's say we have a maybe a constant, right? Const int foo equals 1. And maybe we're old school and we want to say that constants should always be uppercase, right? So I can come in to my application, into my Visual Studio tooling, and under tools options, you can find, or just type in here naming, to search for the naming style. And I want the naming style for C#. And here's where you can actually customize the naming, the code, the naming conventions, the formatting conventions, the code styles that you want to use. So for example, if you're not in favor of var, right? You can come in and say for var that you want to always prefer the explicit type, or always prefer var. Or maybe you say for a built-in type where you can obviously see where what it is, prefer var. But when the variable type isn't apparent, then you might want to change the logic on the other one, right? And vice versa. So you have the ability to customize these. Now, when this feature came out with 2017, there was a challenge with this. So the customizations that you apply in here, be that from your styles or naming. So as I was mentioning, we might want to make a naming change to say that we have a specification which can apply, let's see, add one, that can apply to maybe constants or interfaces or classes. And you want to make sure that like an interface here begins with an I, or the other way. And you can customize these and add your own naming styles and specifications. I'm not going to do that for right now just because I honestly forgot to set that particular demo up. But you do have the ability to customize conventions based off of your application. The challenge here is that these only apply for you and any version of Visual Studio that you have shared this with. It does not apply to the rest of your team. With 2019, they added in this support for the editor config as well. And the great thing with editor config is it's a file that you can include within your repository that then the rest of your team is going to share and be able to leverage those. And so you can configure your settings, configure how you use var, configure the this expressions. All of these various settings, you can go in and configure and tweak and set that up to whatever your style guide is. And then it'll create a .editor config, or you can create one manually. It's just a text file. And here I have an editor config file, and we can specify, for example, if I want to make sure that I'm using tabs versus spaces, then I can use indent style as tab with a 4 space, or if I can have spaces maybe, and that indent size is going to be 2. This is only going to apply for new code, but it's not going to automatically reformat the code that you already have existing. So I'm going to go ahead and leave that back where I had it. I prefer that particular setup. You can also specify that this particular rule applies for all CS files. Maybe a different rule applies for JS files, or basically any type of file based off of the extension. It's how the editor config works. And editor config is not just for Visual Studio. It also VS Code. I think Sublime can leverage editor configs. A lot of the tools that are out there are able to use the same open standard of an editor config. The C# team has gone in and added more customizations around these so that we can then tweak out the additional rules, like the ones that I was showing you in the tools options. And that's how we're going to persist with those. And you can come in and, for example, if I wanted to create a rule that says all async methods need to end in the word async, I can create a rule right in here that's going to enforce that. And then it's an open standard on how you configure all of these. If you look at my hands-on labs, I have a link to documentation specifically around how to write one of these and customize it yourself. I'm not going to go into it here today, but you can see sort of it's interesting where some of the pieces in here, for example, async any methods, it's actually referring to something which we declare right here a little bit below, and being able to specify pieces of code which are only in this configuration components here. It's sort of interesting how they've actually pieced all together. So if I had a rule in my application that I wanted to change, so for example, here I have a remove unused parameter. If I wanted to suppress that rule, I can say suppress that, and or change the severity of it to maybe I don't want to have that as, maybe I want to have it as an error to make sure that the developer actually fixes that. I can go in here and change that to error. It should then update my editor config. And now we can see that the diagnostic for that diagnostic ID is now a severity of error. And we now see that that's an error in our application, right? Let's undo that because I want to make sure that the application can still work. Okay, now that error went away. So here's where we can sort of see how we can customize this and maybe coming up to a standard. This is the set of rules which is going to apply not only to this project, but to all of the projects within my organization. And so if you then have the editor config at the root level of your organization, at the root level of your repo, for example, that's going to apply to all of the projects that are under that particular heading. But in each one of the folders under that, you can have another editor config, which does customizations on that. So let's say in your business domain logic, you want to have certain rules which don't apply in your the data access layer, for example. And you have the ability to customize those through the editor configs. And these editor configs are shared across everybody in your team, which is a good thing. Okay. Any questions before I jump into the next piece here? I know I've been rambling on for quite a bit, and hopefully if it started exciting you, maybe you've already been working in the background to open up a project that you already have and start trying some of these tools and seeing how they work for yourself. One other thing that I will point out is if your developers are ignoring your warnings, you can, in your project, go into your project properties, and under the build, there is a nice little feature in here that says treat warnings as errors. And if you say all there, that's going to force that anything that was previously a warning now becomes an error, and your code will no longer compile until you fix all of the errors, which is great until you realize that once you turn that on, you have to go out and fix all of those errors before, or otherwise you've just broken the build. And you owe the rest of the team donuts for the rest of the day, right? So be careful with that one, but it is a great feature if you want to make sure and enforce that those rules are working. A better way is probably for specific rules that you want to tweak in more and more. You can set up your severity level so that it is not as high, but then maybe bring that up to warning or bring that up to error on a specific rule by rule basis. And be able to help to make your code better that way. So for example, maybe you want to turn CA 2000, which is make sure that everything that implements iDisposable is properly disposed in your application. Maybe you want to enforce that that gets turned on for your application so that you can catch memory leaks, for example. That might be a good opportunity to use error rather than warning at that point. Okay. So we've gone through, we fixed most of the problems. We had a couple things I say I intentionally want to ignore. So let's go ahead and fix this one because we don't need that one anymore. And I think we're looking pretty good with the exception of the ones that I want to explicitly ignore here. So let me come in next and say, so what if I wanted to add more of these tools? Well, how can I do that? Well, here I'm going to go into dependencies and manage Nougat packages. So there are a bunch of, in C#, static analysis tools, which when C# was rewritten, the compiler was rewritten for C#6, that when they wrote the compiler, they actually made it extensible so that other people could actually extend upon that. So here I'm going to go in and add, manage Nougat packages. I'm going to look for a Roslyn analyzer. I happen to know a couple off the top of my head. So there is fxcop, which I mentioned before, right? And they have now built the fxcop as a code, fxcop analyzers. And the this is actually people on the C# team that have done these. Let's see here. Package has been deprecated and the legacy no longer maintained. Okay, I want the other one then. Where is the real fxcop? Maybe they've pulled it all into .NET itself. I thought it was there. I'm going to keep on going anyway, and I'll search for the answer on that one offline here. So what about CodeCracker? This is an open source project that I helped contribute to. And I'm going to go ahead and pull in CodeCracker C#. I'll just throw a bunch of these on. I mean, you can try them. If you like them, you can keep them. If you don't like them, you can get rid of them. Realize that these do install on a per project basis. So if you want, then you might want to, you're going to have to install that separately for each project that's going to be in your solution. Wow, notice when I installed CodeCracker, it found that there was actually an error in my code. If you remember, this actually compiled before, but now there's an error. So I might want to try to figure out what's that error that CodeCracker is telling me about. Now here I have a read-only URI blog. Anybody see any problem with that? Well, is that going to compile? New URI takes what? Takes a string. That looks good. Problem is, that string is not a URI. So it's able to detect in the domain of URIs that what you're actually passing into it doesn't agree, and that could potentially cause a runtime exception rather than a compilation exception. And as we all know from development, catching things at compile time and as far to the left as you can get on the developer process, the cheaper it's going to be to actually fix these and be able to resolve those. Because once we ship it out to the into the wild, it's much more of a challenge to actually fix things and find them, and much more expensive as well. So let's go ahead and fix this one. So we got HTTP, right? Yeah, thinklink.com, great website. I highly recommend it. It does have a little bit of a security problem right now because HTTPS needs to be refreshed, but otherwise it's a good place. Okay, so we got that one. Let's see. Now that we got this installed, we found some other things we might be able to optimize. So what can we do to be able to fix this one? Here we have argument exception. Input is a string. Maybe we want to use name of. If you don't know what name of is, it allows sort of type safe. So if I wanted to change this to input one, about input one and do a rename. I hate it when I type too fast and get things out of whack there. So let's try that again. Going to use name of here. And up here, let's just change that to input one, do a rename. And now we see that because we're no longer using magic string on here, we're using the name of, it can actually be refresh, a rename specific in there, right? Here we have that exception that I wanted to hold off onto. Let's see what it's recommending for. We can either use discard, which is a sort of new way of handling variables that we're not actually going to use. I don't really want to use that because we don't want to allocate anything to that. We could remove the entire try catch block because we're not doing anything other than just catching and swallowing exceptions, which actually I think I want to go that one. We could go in and say we have a catch block, but we need a to-do comment. Well, I recommend to-dos. You probably want an analyzer which says you should never leave a to-do in your code, because in most cases, when you have a to-do in your code, it's not going to be to done. And they're just going to leave that legacy code in your application, which is not a good thing. Or I can insert an exception into the catch. Well, I'm going to use this one, which actually in the CodeCracker code base, we have a little bit of a bug where we should be removing that whole block. So if you want to learn about more and contribute, go out to CodeCracker and find that bug and resolve it. Hey, great way of learning. Okay, here we have person equals new person. Boy, that's redundant. How about if we use var? That's a little bit better. And how about if we use a object initializer to simplify that, and we can then inline our temporary variable, because we don't need to do that. And why don't we just go ahead and convert this and make it more functional? But I don't really want this as a function. I want this actually as a property. But yeah, that property, I want to actually on the getter, maybe convert that to an expression body member. And yeah, so my code looks a little bit better now. How's that look? That's not too bad. Do something. It wants everything on separate methods, I believe. Actually, we can just use this expression body there too. And removing code, great thing. Okay, let's see here. What else do we have? I did that one already. That one's good. Okay, here as a link guy, one of pet peeves of mine is to do a where and then a .any or .first, where we can just go ahead and inline and not have to have a separate method for the any and just use the predicate inside of the any itself. Less code that we have to write. Okay, here is how to not write a Fibonacci checker, because as we all know, the switch statement is going to be much better instead. Okay, here, what's wrong with this code? We got a for each loop that's going to iterate and concatenate a string inside of that for each loop. Anybody know what's wrong with that? Yes, of course, we should be using a string builder, which is going to manage our memory better. If you didn't know how to use a string builder, well, now we know how to use a string builder, because it told us that here's what we should do, and here's how we fix it. So now we can learn and get it better, right? There's another one. If I install the Roslinator, for example, it would add a analyzer on this one that says you should not have an order by and then an order by, because the second order by is going to overwrite the first order by. So it actually recommends using a .then by. And if you didn't know about then by, now you do. And one of the great things about these analyzers I find over time is it helps me learn, helps me understand how code should be written better. Here's another one that we have a person. Person happens to derive from is a disposable. So I should, on that disposable, dispose of person. Okay. But you see the little suggestion here that's underneath the using. It's saying there might be something else that you can do here. So I can now, as of C#8, use a simple using statement. And that way, as soon as this code goes out of the block goes out, then it's going to dispose of that. And I don't have to have a whole using block anymore for those. So again, it's a great way of learning in your code. Hey, maybe there are better ways of writing my code. It's great if you're a single person on a team. It's great if you're trying to enforce it across the rest of your team and all of those kinds of things. So I could go in, tweak the rest of these. The samples are available on my GitHub. So and also with my labs, I help step you through, through this process, going through, fixing all of these and trying to do that. So if you're not familiar with doing these, I recommend going out and trying to step through the process of doing one of these, and you'll learn a bunch of the different kinds of rules that are out there to be able to make your life easier. And if you don't understand what a rule is, just go ahead and click on it, and it'll take you to a help file, which will tell you exactly what that rule is, why it's there, when you should ignore it, when you should care about it, and all those kinds of things. Okay. So let me come back into my slides, because I jumped past a fair amount here. I just want to make sure that I'm covering everything I want to do. Talked about you need to be able to make this extensible. It used to be before 2019, there was a separate file that you would be able to customize the rules for. That's now been basically replaced by the editor config file. So the rule set files, if you use those in the past, you should be able to convert those. And I have an actual tool, little tool on my GitHub that can convert a rule set file over to an editor config file, in case anybody's interested in that one. But you should be able to customize it not only for C#, but maybe customizing the JavaScript lint, JS hint, CSS style lints. Any of these tools, they should have some level of customization so you can not necessarily have your code be ruled by some external party saying this is how thou shalt code C#, but more of these are the guides that we recommend. And then what are the rules that I actually want to apply? So for example, if you apply fxcop and codecracker and roslinator and stylecop can be very opinionated. Sometimes the rules don't agree with each other, and you'll have to go in and tweak the rules to say, no, this is what our style is supposed to be. That also depends on, have we gone through the process of having discussions within our teams to figure out what our style really is, right? That's important. Don't want to sort of gloss over that. But yeah, you have the ability to customize your code styles. Again, if you do it directly through this tool, that's only going to apply for your version of Visual Studio and any of the other computers that you log into as you, because it uses a roaming profile for those settings. It's better to use the editor config than to customize them directly here. If you want to add your own naming styles, here was how we can add for constants, add a rule that says that they should be all upper and set the capitalization for that. And then we can apply that for constants, for example, if we want to be old school around our constants, so that maybe they should be all upper, or maybe all upper with a underscore word separator, right? I'm sure we've all seen that kind of a C mentality of code in that regard. Editor config is a better option for maintaining these. Here we see, for example, we have a rule that says for all files, the end of line should be this. For CS, Python, and XMLM should have an indentation style of tab, but for JavaScript, maybe has 2 spaces indentation style. And then there's other configuration optimizations that you can make in these. And again, this applies not only for Visual Studio VS Code, but for a number of the other editors as well. It's an open standard. We saw how we can add an analyzer from Nuget. Another very popular static analysis tool, and this is really used more on the CI/CD process. And so every time you build through a continuous integration pipeline, you can then have Sonar, for example, capture the metrics, apply the rules. It has its own set of rules. There is a Sonar analyzer, which is Roslyn based, just as I showed codecracker and the ones that you do there. So that way you don't have to wait for the build process to run those analyzers. It will run as part of your development process, and you'll see it immediately and be able to fix it immediately rather than having to wait to check in and pull requests and all those kinds of things. Another nice thing that Sonar gives, not only the ability to customize the rules, but it also gives that trend analysis to say, is our code getting better or worse over time? And being able to track some of those areas. It has rules that other systems may or may not have. For example, it has the ability to check for certain security vulnerabilities, like do we have secrets that are part of our application? And like Sonar works across multiple languages. It's not just related to JavaScript, C#, C++, Python, Ruby. It has plugins for lots of different languages in there. Okay, the last one I want to take a look at regards, so how do we build our own? And maybe we want to try to detect a maybe domain-specific error, like I showed you with the controller before. Well, in order to do that, I'm going to take advantage of the C# compiler, which was rewritten. Codename for this is Roslyn, and you'll still see the Roslyn as part of the GitHub repository. And with Roslyn, what they did was they not only, previously before Roslyn, we had, here's our C# code, CS files, and then we had this black box of a compiler, and that generated intermediate language, which would then be compiled at runtime and JITted and run. And so when they rewrote the compiler, they wanted to make sure that it was extensible so that others could take advantage of the lexer and the parsers that they had already written, and being able to extend and add their own ones. So like codecracker, we take advantage of the ASTs, abstract syntax trees that the compiler generates, and we can just consume those and interrogate our code based off of information that we're trying to look for, looking for patterns of certain kinds of things. And that way we can interpret and catch that before we go to the compiler and full compilation process. So what does it take to actually create one of these analyzers? Well, there's lots of steps. And I'm going to jump right back into Visual Studio here. So let's say we wanted to do one. So let's take an easy case here. First one, let's say we have some developer came in and wrote var x equals 1. Bad developer, right? Because we don't want single character variables. Well, first thing we have to do is try to evaluate this code and figure out, well, what does this code look like and what are we going to do with that? So what you do is when you install Visual Studio, there is a compiler SDK that you can install and add some Roslyn kind of capabilities to that. One of those is the syntax visualizer. So if you go, once you install it, you can go to View, Tools, Other Windows, and I have a syntax visualizer on here. Oh, where is it? Right there, right? And so I'll enable that, and that allows me to take a look at my code. I don't recommend having this open while you are actually writing your code, because it's going to show you a lot of more things than what you really care about, and it may slow your process down a little bit. But if you're trying to write one of these or figure out a little bit more information about your code, then this is where it's going to come in handy, because it's actually going to give you the entire syntax tree of each piece of your code. And notice as I'm clicking around in this tree, it's clicking around to different pieces of that line of code. So for this one line of code, we have a local declaration statement that's a variable declarator that has a member name with var, and then a variable declarator that has an identifier of x, and an equal value clause that has an equals token, which has some white space around it, and a numeric literal expression of 1. Whew, that's a lot. If anybody's actually written your own compiler, you have some feeling of what this actually takes. The great thing is we don't have to write all of this ourselves. It can figure that out for us. And if we wanted to, we could also see a directed graph syntax of this to actually see the tree itself. So I want the local declaration statement. There we go. So here we have the local declaration statement, variable declarator with the var. And so here we have statements, we have tokens, and we have trivia. Now, if you're writing your own compiler, you don't care about the trivia, right? Trivia is white space. And most of our languages, other than Python, don't really care about the white space. So, but we do care about the white space if we're going to take code and rewrite it and create new code. So what could we do to detect that we have a problem where we have code that's var x equals 1, and we want to, for that particular token, find any cases where it's a single character, and then at least tell the user, hey, I don't like this, you need to make a change to it, right? And so let me go ahead and just bring that particular demo up here real quick. And while I'm doing this, let me ask, how are we doing on time here?
We've got a few more minutes.
Okay. I'm not going to write it all out myself, but I'll just show you the code, because I'm not going to teach you how to do this in a few more minutes, right? But I can show you what this actually takes. And again, I have the online lab that will help walk you through this. So here I have a solution. I've created a new analyzer. There's analyzers with code fixes. The analyzer with code fix is going to say, hey, here's a problem, and I know how to fix it. On an analyzer, it just says, hey, I know that there's a problem. I don't know how to fix it, though. Right? And that's the case with this. We don't know how to fix it, but we can detect that there's a problem. So we have a bunch of plumbing things, which is going to indicate what's the title, what's going to appear inside of the IDE for setting those. We can set what is the default severity level on this. We can set what is the ID, which we're going to refer to. So remember when I was showing you the rules, you could click on any of the rules and it would say, okay, this was CC001 or IDE 0135, right? So that you can number those and maintain it from there. And then you're going to initialize the rule. And on the initialization, you can then have the customization of saying what kinds of things are you going to pay attention to. So on the context, you can register for a lot of different kinds of things. So we can register for code block, compilation action, operation action, semantic model. Semantic model means it has to compile, essentially, and be able to get more fuller information. We want to make sure when we're writing these, because this is going to be evaluated anytime the developer types on their keyboard. And so we want to make sure that this is going to work as fast as we possibly can off the smallest scope that we possibly can. So in this particular case, we're going to have a syntax node that we're going to be paying attention to, because as we saw, it's an individual node of syntax. And we want to evaluate, well, we can do an add expression, an ampersand token, a arg list. Yeah, there's a lot of stuff in here. A lot of stuff to understand around how the C# language works, right? So I happen to know in this particular case, we have a local declaration statement. How did I know that? From the tree, which we got from over here. So for example, if I come in here again, var x equals 1. It's getting late. I can't type anymore today. Okay. And if you remember over here, we have a local declaration statement. Local declaration statement. Good. So we're going to register that something is going to operate over a local declaration statement. What is that? We're going to analyze the local declaration statement, which is a delegate pointer to the implementation. And in this one, it's going to say, well, I'll give you the node that you're looking at inside of the tree. And I can say, well, if the node declaration variables, if it has variables, if it doesn't, exit out. We don't need to evaluate something that doesn't actually have variables defined on it yet. But if it does, then I'm going to for each over the declarations on these, because I don't know if you remember that C# you can actually declare multiple variables within a single statement. Most of you don't, but you can do this. And so they had to make sure that they can support that. So now we're going to for each over each declarator in the variable. If it doesn't have anything, exit out, stop working, right? Don't spend cycles when you don't need to spend the cycles. Then we can get the identifier. As long as the identifier exists, then I can check, is the length 1? If so, hey, Houston, we have a problem. I'm going to report that problem and make sure that the user is aware of it. So now I can run this, and this is the way not to debug one of these, is to hit F5 or debug and start spinning this up. Because what this is going to do is it's going to spin up a second instance of Visual Studio. You can't, inside of one of these analyzers, put a breakpoint on the analyzer and have that running in the current version of Visual Studio, because when you hit a breakpoint, how can you step into the code if Visual Studio is broken, right? So they actually are spinning up here, and you see a lot of stuff that's spinning into memory right now. They're spinning up a second experimental Hive version of Visual Studio that you can now debug into, which only has what you're plugging in for this particular test that you're checking against. And so right now I have a Visual Studio on another window that's trying to launch, and I can't even drag it over yet. Here we go. So I'm dragging it over. It's launching, and now it's applying the rule that I had. I could go into my code, I could put a breakpoint on there, but through the magic of TV, we should see that this one is going to get evaluated, and these magically you see a little squiggly there, right? And if I hover over the squiggly, it says that the analyzer 4, which was the name of the analyzer that I created, type name X is too short. Pretty cool. Now, to do that, yeah, there's a lot that you have to understand. It's doable. I don't recommend most of you go out there and start writing your own analyzers. The capability is there if you want. However, most of you probably can take advantage of analyzers that other people have already written and use those in your current code bases, customizing them to your needs to be able to improve the quality of the code that you currently have. So with that, I'm going to sort of wrap up here by a couple key principles with static analysis. One, start early. Don't wait until you have a 200,000 line code base that you want to then try to apply one of these onto. It's going to give you way too many things that you want to take a look at. If you do have to do that, go through and figure what is the minimum set of rules that I want to apply on my code at this point in time. And then over time, slowly start to incorporate individual rules one at one. And you can then fix individual rules a lot easier because it's basic, rote changes that you often have to make, rather than trying to apply, thousands of code changes in a single pull request. Do your team a favor and don't do that, right? But make sure that you're running these often. Hopefully, you're running them every single time, while you're developing. And as Ken Ross just said, we do have a giveaway for JetBrains license, which, hey, they have ReSharper, which does static analysis, right? Make sure to customize them for your needs. Make sure that augments your entire software delivery lifecycle, so that it's not just a tool that you have to use, but it's a tool that you want to use, right? And this allows your code reviews to then focus not on code smells and on syntax, but on domain issues and making sure that your application is doing what you want it to do. So with that, a couple links. Again, the GitHub IO link, very top there, gets you access to this presentation and a whole bunch of other ones. And I'm actually going to go way back to the very beginning one to include the other links for this presentation, which is the analyzers link, and the Roslyn Labs, which if you want to get deeper into trying to understand Roslyn and writing your own, then try those labs. Again, I think that there are a couple of changes that I need to make to those that I haven't made yet. So if you find them and you want to do a pull request, I'm all ears. I love the community helping to contribute. So with that, I think I'm pretty much out of time, almost out of voice, but I hope you learned stuff. Open to questions that you might have at this point. But otherwise, thank you everybody for attending.
Thanks, Jim. That was really quite fascinating. And picked up a few good plugins to add to my editing environments as well. So very cool.
Awesome.